Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come back and watch it. So let me start the recording. And so thank you. Now that this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. And without further ado, I will hand it off to our presenters.
Hello, everyone. I hope everyone had a great week. And today we're going to cover linear and nonlinear systems of equations. If you're in 1324, Ms. Patricia just posted the link so you can head out to your 1324 room. If at any time you have questions, please let us know. So we will get started. Okay, so this topic will be for chapter 7, which most of you will be looking at starting next week if you haven't already. And so we wanted to kind of introduce it so that next week you guys will be prepared for what you see coming up. So linear systems are basically linear equations that have more than one equation. So it needs to have at least two equations in order for it to be a system. Later, we're going to talk about a nonlinear system, and those can be a linear equation, quadratic equation, exponential, as long as it has two or more equations. Now, a solution is an ordered pair that satisfies an equation when you substitute it into the equation, and we're going to look at some examples here in a little bit. And then a solution set is a set of all ordered pairs that will satisfy both equations. Okay, so we'll look at these two definitions in more detail in a second. And so as I mentioned earlier, we can have linear equations or nonlinear equations. And then there's different ways to solving the systems. And we're going to discuss two of these in detail, which is the substitution and the elimination. And then the graphing is also a way to solve a system, but it is not the most accurate because depending on your handwriting, for example, you might not plot the points in a straight line. And so it's not the most accurate, but it still works. Now the solution we're looking for is going to be the intersection of the graphs. Okay, so I have three examples here. And so the first example is, you can see there's two lines. So I'm looking at this example. Let me get my pen out. And you can see there's two lines. So this is a linear system. And so we want to look at where is the solution to this system. And so as I mentioned earlier, the solution is going to be the intersection. So we're looking at this point 2, 0 is our solution. Okay. So what would be the solution for our second graph? And you can type it in the chat if you like, if anybody wants to try out the answer. Oops. Okay, so the intersection of in this case, this is a nonlinear system because we have a parabola and we have a line. And so anywhere that they intersect, so it intersects here and it intersects here, those are going to be considered solutions to the system. And so our solutions are 0, -1, and 2 and 1. So let's look at the third graph. This is a nonlinear system, again, because we have a line and we have a parabola. So the solution for this system is going to be where? So notice that the line and the parabola do not intersect. And so when that happens, we see that there's no solution. Okay, any questions on how to identify a solution based on a graph, given a graph? Okay, so now let's say we have a system, and usually you'll see a system written in this form here with the two equations and the little brace on the side. And so we want to know, is the point 0, -4 a solution to this system? So in order to check that, we're going to substitute our point 0, 4, 0, -4 into the first equation. So I have 2 times 0 minus -4 equals 4. And if we simplify, then we have that 4 is equal to 4. And that is a true statement. And so we say that it satisfies that first equation. However, in order for it to be a solution, the point must also satisfy the second equation. And so we need to check the second equation. So for x, I replace it with the 0, and y, I replace it with a -4. And so here we would have, this should have been a, let me see, no, it's okay. So then we get -4 is equal to -9. And this is a false statement. And so that's why I put the x here. So this is not a true statement. And so since this point 0, -4 satisfied only the first equation, then we say that the point 0, -4 is not a solution to the system. Okay, so let's try the second point. So again, we want to plot in the, substitute the values for x and y. So we're going to have 2 times -1/2 minus -5. And if we simplify, then we end up with 4 is equal to 4, which is a true statement. So we'll check the second equation. So I'm going to substitute -1/2 x and -5 for y. And if I simplify, I get -4 minus 5, which is -9 is equal to -9. And that is a true statement as well. So we can see here that both equations, or this point satisfies both equations. And so therefore we can say that the point, let me go back, that the point -1/2 and -5 is a solution to the system. Okay. Now, one of our goals for the next sections in 7.1 and 7.2 is going to be to solve the system. So you're going to be wanting to look for that point that satisfies both equations. And sometimes it could be more than one point. And then sometimes you can, you'll see that you have no point that satisfies them. So we're going to look at both methods side by side. And the good thing about these methods is that you'll be able to choose whichever method you prefer and whichever method you feel comfortable with. And no matter the method that you choose, you'll always end up with the same answer regardless of which method you use. So if we look at the substitution method, the first step is to choose one of the equations and solve for one variable. So here I chose the first equation, x plus y equals 4. And then you can also pick whichever variable you like best, or whichever one is easier to simplify for. So in this case, the x and the y, they both have coefficients of 1, so it really doesn't matter which one you would pick here. And so I'm going to go ahead and solve for x. So I'm going to subtract y on both sides, and I get x is equal to 4 minus y. So that is your first step, is just choose one equation and solve for the variable. So step 2, we want to take the result, which I have here in red, and we're going to plug it into the unused equation from step 1. So notice that we didn't use x minus y equals 2. So I'm going to go ahead and use that equation. So anywhere I see an x, I'm going to substitute 4 minus y, and then I have minus y equals 2. So this process here is helping us to solve for at least one of the variables. So now we solve for the variable. So we have 4 minus y is negative 2y is equal to 2. I'm going to subtract 4 on both sides. So we get negative 2y equals 2 minus 4. And then if we keep simplifying, we end up with y is equal to 1. So now we have one of our points, one of our variables. And now we need to look for the second variable, which is x. So step number 4 is going to be to use back substitution. And we're going to take our answer from step 3, which is y equals 1, and we're going to substitute it into one of the equations. And at that point, it doesn't matter which equation you pick. I went ahead and chose the first one. So I have x plus y equals 4. And I'm going to substitute y. So I'm going to have x plus 1 is equal to 4. And I end up with x equals 3. So when you're entering your solutions into WebAssign, they do want you to put it as an ordered pair. And so I would say that my solution is 3, 1. My ordered pair is 3, 1. So that is the first method. And then the second method is called the elimination addition method. Some books call it the elimination method. Some books call it the addition method. And then some books call it elimination dash addition method. And so the first step for this method is to choose a variable to eliminate. So this is the opportunity to get rid of that variable that you don't like. So if you don't like x, you can get rid of the x. If you don't like y, you can get rid of the y. I'm going to choose to eliminate y. And so I'm going to write down my two equations here. And so I have our second step is going to be, it says here, make sure that the variables are opposites of each other in the equations. And what I meant to write instead is make sure that the coefficients of the variables are opposites. And what I mean by that is, let's say I had 2x plus y equals 4, and then I had negative 2x plus 3y equals 10, and the negative 2 and the 2 are opposites of each other, okay? And so we want to make sure that we have, let me see. We want to make sure that we have opposites of each other, okay? And you'll see why here in a second. So I decided to eliminate y. And so if you notice, the coefficient for the first y is already a positive 1, and the second one is a negative 1. And so that is good. They have opposite signs. And since they have opposite signs, then I'm going to write each equation. I'm going to be adding these two equations. So we're going to be adding the two equations. So we have x plus x is 2x, and then the y plus the negative y is 0, and then 4 plus 2 is 6. Divide by 2 on both sides, so we get x is equal to 3. So here we were able to solve for x, and now we're going to go to step 4, which is to back substitute. So we're going to take our answer and plug it into the equations. Again, it doesn't matter which one you choose. So x, instead of x, I'm going to write 3 plus y is equal to 4. Subtract the 3, so we get y equals 1. So you can see that we end up with the same answer, but we use a different method, but same answer. Okay, so for me personally, I use the method depending on how the equations are given to me. And so I think in our next examples, I'll be able to explain what I mean by that. Okay, methods. And then the third method would have been to graph each of the equations, but the graphing sometimes might even take a little bit longer. And again, it's not the most accurate. Okay, so let's try another example. So it says solve the system of the equation using any method. So this is your choice, right? You can pick the substitution method, or you can pick the elimination method. So if I look at both equations, then I can see that the first equation already solved for y. So since I already solved for y, then that makes it a little bit easier because I don't have to worry about solving for an exponent. So here's my y is isolated already. And so I'm going to go ahead and use the substitution method. And so notice that the first equation solved for y, and we're going to use a substitution method. And so what I'm going to do here is, since the first equation is telling me that y is equal to 2x plus 3, Then I'm going to take that information and I'm going to plug it into the second equation. So I have x plus 2y. Well, instead of y, I'm going to replace it with 2x plus 3. And so that's going to look like x plus 2 times 2x plus 3 equals negative 4. So now I can simplify and solve for x. So I'm going to have x plus 2 times 2 is 4x and 2 times 3 is 6 is equal to negative 4. Gather our like terms. So we have x plus 4x is 5x and negative 4 minus 6 is negative 10. So if we divide by 5, then we get x equals negative 2. And so these were the first three steps. The first step was already done for us because y was by itself. And so the last step here is to back substitute. So I'm going to take my answer and I can plug it in. I can take this answer and I can plug it in to this equation or to this equation. And so let's go ahead and plug it into the first equation. So we have 2x plus 3 equals y. So if I let x equals negative 2, then I end up with 2 times negative 2 plus 3 is equal to y. So we simplify. Negative 4 plus 3 is negative 1. And so last, to write my answer, I'm going to write it as an ordered pair of negative 2, 1. I have the first braces here to represent that that's my solution set. And then, of course, the parentheses is for my ordered pair. So be careful when you enter your answers on WebAssign because sometimes they already have I see this quite a bit, they already have the brackets out here. And so some people will come in and put another bracket and then they put the numbers and then it's going to count it wrong because the brackets were already there. And so if that happens, then if the brackets are there, you just put in your numbers. So always be careful on what they already have there for you. Okay, so let's look at another example. So what method would you like to see? Like what method would you think would be the one that's easier to use according to the equations that they give us here? Now, the good news about the question that I'm asking is that there's not a wrong answer, right? I mean, it's totally an opinion type of question. And so Mr. Garcia says substitution. And so substitution is going to be the one that I personally would prefer in this situation. And the same reason as before, the y is already by itself. Okay, so let's go ahead and use the substitution. Now, if you like the addition method, then you can still use that method, but you would have to take that y and place it on the other side of the equation first. Okay, so let's look at this problem here. So I'm going to take whatever y is 2x minus 3, and I'm going to substitute it in for my y's. And so I'm going to have 3x minus 2 times 2x minus 3 equals 7. And then we're going to simplify. So we have distribute the negative 2. So we have negative 4x plus 6. Gather your like terms. 3x minus 4x is a negative x. And if we subtract the 6 to the right side, we get 7 minus 6, which is 1. Divide by negative 1, so we get x equals negative 1. Any questions on that? Okay. So then we can back substitute, and again, we can take our answer and plug it into whichever equation you prefer. So we can come up here, or we can come up here. And so whatever equation you pick doesn't matter at this point. Okay, so let's go ahead and plug it into the first one or the second one. So we have y is equal to 2. Instead of x, I'm going to replace it with negative 1. So I get negative 2 minus 3, which is negative 5. And so my solution is negative 1, negative 5. Okay, so let's continue on. In a little bit, we'll get to problems that are nonlinear as well. Okay, so here's another method, another example. And so for this one, again, it's your choice. You can use elimination, substitution, or graphing. Okay, so notice that in these two equations, you don't have a variable that is already isolated. And so my preference would be to use the elimination addition method. But again, Mr. Carizales' method might be substitution, and that would be okay. We would both end up with the same answer. Okay, so we're going to choose a variable. And so if you want to get rid of your x's, then we can get rid of those x's. Okay, if you want to get rid of the y's, then we can get rid of the y's. And so here we're going to eliminate the x. And so notice that for the x, I have a 2 and I have a -5. So these two coefficients are not the same, or they're not opposites. So somehow I need the 2 and or the coefficients to be the same. Well, there's no way for me to make a 5 and a 2. In other words, if I had a 4, then I can multiply the 2 times 2 to get a 4. But there's no way I can do that. So I can multiply the 2 and the 5 to give me a 10. Okay. And so, or you could say I can multiply the 2 by 10 to get 20 and the 5 by 4 to get 20. So whatever coefficient you choose here doesn't matter. I always try to do the least common one. Okay. So I'm going to multiply this first equation by 5. So I'm going to have 5 times 2x gives me a 10x, and 5 times -7 gives me a -35y, and 5 times 3 is 15. So whatever number you multiply, just remember that you have to multiply all the way across to both sides of the equation. So my first equation is now 10x minus 35y equals 15. Now the second equation, I needed to have a -10. So I'm going to multiply it by 2 as well. So I'm going to have 2 times -5 is -10x. 2 times 3 is 6y. And 2 times 7 is 14. So I've created two new equations, but in reality, we're not changing the problem because we're just multiplying by 3, but we're doing it on both sides. And so essentially, it's just multiplying by 1. So we have this new equation, and we have this new equation. So we're going to add the two equations. So I'm going to write them down here. And so I have 10x minus 35y equals 15. That was the first equation. And negative 10x plus 6y equals 14. That was the second equation. So if I add 10x and negative 10x, I get a 0. And negative 35y plus 6, 29y. 15 plus 14, 29. So if we divide by negative 29, then our answer is y equals -1. And so now we can back substitute. And I'm going to plug that -1 into either of the equations. In this case, I chose the first one. So I'm going to have 2x minus 7, and then y is -1. So -7 times -1 is +7. So I end up with x equals -2. So my solution set would be -2, -1. So if you tried substitution, then at the end you should end up with the same answer. Now with substitution, the tricky part here is that you might end up with a fraction. And so if you really love fractions, then that would be the way to go. If you're not as excited about fractions, then you might want to go with the addition method. Okay, so here we have another one. So we can, again, it's set up nicely for the elimination addition method. And so we can get rid of the x's again, or we can get rid of the y's. And so that's really going to be up to each of us. So I'm going to get rid of the x's here. And I'm going to need the x's to have the opposite numbers of each other. So the second one has a -4, and the first one has a 2. So this 2, I need to make it into a 4. So I'm going to multiply that whole equation by 2. Okay, so 2 times 2x, and then 2 times negative 5, and then 2 times 6. And so we end up with 4x minus 10y equals to 12. Now I can add both equations. So I have the brand new equation here, 4x minus 10y equals 12. And then I'm going to add it to negative 4x plus 10y equals negative 11. I mean, negative 1. So when we add them, 4x minus 4x is 0. Negative 10 plus 10 is 0. And then 12 minus 1 is negative 11. So we ended up with a false statement here. And so when that happens, then that means that this solution is no solution. And so if you recall, if there's no solution, if you were to graph these lines, they're going to be parallel, meaning that the lines will not intersect. Now, the other word we use to represent no solution is inconsistent. Okay, so if you have 0 equals 0 or negative 11 equals negative 11, then we would say that there's many solutions. Okay, any questions on that? And many solutions, just so, let me just take that opportunity here really quick. Okay, so if we were to graph the lines for many solutions, if I draw my line here, that would be the first equation. But if I draw my second line, then it's going to be on top of this blue line. And so basically all the points on the lines are going to satisfy both equations. And so that's why we say that it's infinite many solutions. And we say it's a dependent system. And then if we are just graphing the other lines, we have a red line here, and then we have a blue one, then this would be one solution, and that's a consistent system. Okay, so let's see. Okay, so word problems, yeah. The word problems, so systems are used to help solve real world application data, right? And so this is just an example. The given amount of annual interest is earned from a total of 9,000 invested in 2 funds paying simple interest. Write a solve. It says write and solve a system of equations to find the amount invested at each given rate. So you have two. You're going to have 2 investments for a total of 9,000, and this system annual interest is 380, and the first rate of your first investment is 2%, and the second rate for the second investment is 6%. 6%. So we're gonna call these 2 investments A and B. So we'll have investment A, or the funds, right? And then the second fund would be B. But together, we're gonna have $9,000. Okay. So maybe one has 3,000 and the other one has 6,000, and that's what we're trying to figure out. So what we can do is then we can let the first fund be the one at 2% and the second one be at 6%. And so we take the data or the information they give us in the word problem, and we try to break it down into something that we can use. So we can come up with equations. The first equation is taking fund 1 plus the second fund, and I know that it should only be $9,000. And then the interest for the first fund we said would be 2%, and the interest for the second fund we said would be 6%. So we're going to write those as decimals. And then the total interest for both of these for that year is 380. And so what we have is 2 equations. And so now we can use the substitution method or the elimination method. One of the things is you might not like decimals too much. So we can get rid of the decimals by multiplying by 100 all the way across. So 100 times 0.02 would become a 2a, and 100 times 0.06b would become 6b, and 100 times 380 would become 38,000. And so that's a little bit easier to look at than the one with the decimals. So I can take both equations and we're going to eliminate a. So we're going to multiply by -2 to the first equation. So we get -2 times a is -2a, -2 times b is -2b, and -2 times 9,000 is -18,000. And so we have -2a plus 2a is 4, and -2b plus 6b is, I'm sorry, so -2a plus 2a is 0, and -2b plus 6b is 4b, and then 38,000 plus 18,000 is 20,000. So we end up with b is equal to 5,000. So from the $9,000 that you had, we're going to invest 5,000 of those dollars into the fund B. So now we need to figure out what A is going to be. So we can back substitute it. So I have A plus B. B is 5,000 and equals to 9,000. So if I subtract 5,000, then I get 4,000. So here the person invested 4,000 in the first fund and 5,000 in the second fund. Okay, so using the system of equation help us to solve and set up a system that we can then use to solve the problem. All right, so nonlinear systems. So again, by nonlinear, it just means that at least one of the equations is not a line, okay? So if you look at these pictures from earlier, these are the nonlinear systems because we're working with a system that has at least one parabola. But you could have a circle or you could have an exponential function. So not just necessarily a parabola. Now the methods, they still work the same. You can still use the elimination method, or you can still use the substitution method, or you can still graph. Okay, so if I have these two equations, the best method probably, or for at least in my opinion, would be to use the elimination method since none of the variables are isolated. And then if we look at y, the y, it's already set up for us. One is negative, one is positive. So I'm going to use the elimination method. So we're going to cancel out the y's. So we're going to have x squared plus 4x. So we have x squared plus 4x. And then negative y and y is 0. So then we have equals to 0. So now you can see that what you're left with here is a quadratic equation. And so we have so many different ways to solve it, right? We can factor out common terms. We can use quadratic formula. We can factor. So here, we're going to just go ahead and factor out an x. Okay, so if I take out an x from the x squared, I get x. If I take out this x, I get a 4. So now I can use the zero product property and set x equal to 0 and x plus 4 is equal to 0. So I end up with x equals 0 and x equals -4. And so now I have two x's, whereas before I had one x. So we have to go ahead and identify the y for each of these x's. So we can start with x equals 0. So we'll let x equals 0. And I'm going to use the second equation. So 4 times 0 plus y is equal to 0. So that means that y is going to be 0. So one of my points would be 0, 0. And then I'm going to let x equals -4. So 4 times -4 is -16. So if I solve for y, then I get y equals 16. So my points are 0, 0, and -4 and 16. Okay, so here, oops, let me get my pen out. So the first equation looks like it's going to be this here probably. And then the second equation is going to be something like this, somewhere over here. And I'm drawing the graph really bad right now, but um, anyways, it's going to intersect down here. Oh no, somewhere up here. So did I draw my parabola wrong? I did. So the parabola should be up here. So let me just redo that really quick. So if you were to graph this, these new tools are kind of hard to use sometimes. Okay, so we're going to have a parabola here, and then you're going to have your line, which is at negative 4x. So it's going to go something like this. Oops. Oh my goodness, it doesn't let me. So let's say here's negative 4. So your other point's going to be up here somewhere. Okay, so that is your solutions for the system. Okay, so let's try another one. So we have x minus y equals negative 5 and x squared minus y equals negative 6. And so here we have a line, and then the second equation is a parabola. So again, you can use any method you like. I'm going to choose the elimination method and get rid of the y's. And so I'm going to multiply the first equation by negative 1. So we have negative 1 times x, and negative 1 times negative y, and negative 1 times negative 5. So we end up with negative x plus y equals to 5. So we set it up, and we add them, we get x plus x squared is equal to negative 11. So our y's are going to cancel. Again, it's quadratic, so we can use any different, any method that you like. So in order to solve it though, I need to bring this 11 to the left side. So I end up with x squared plus x plus 11 equals to 0. And I'm going to use the quadratic formula since this is not factorable. And so if we plug in our numbers, we have b is 1, so we have negative 1 plus or minus the square root of b squared, so b is 1 again, minus 4 times a is 1, and then c is 11. So we end up with negative 1 plus or minus the square root of 1 minus 44, and so we end up with a negative in the square root. And so what happens there is we can't, it's going to have an imaginary solution. So we say that there's no solution, so the system will be inconsistent. Okay, so there's no real solution. So we say inconsistent. Oh, I forgot to divide by 2 there, right? Thank you. Okay, so what kind of equations do we have for this next system? Does anybody remember what the first one is? Let me circle it. So what is this here? Is it a line? Is it a parabola? It's a circle, okay? And what about the second one? I gave the answer? Okay, so what about the second one? 3x squared minus 16y equals 0. Is that a line, a circle, parabola, rational function? A parabola. Okay, cool. So we might end up with, let me draw this. So we might end up with a circle and a parabola, something like this, or the parabola could be down. And so that's what we're going to figure out where the solutions are. Or maybe there's no solutions. So the method here that we could use is elimination or substitution. And I think I would want to get rid of the x's. So I normally if I have to eliminate something, I normally eliminate my x's. Okay, so here we have the first equation. If I multiply it by a negative 3, let's see what we get. Okay, so if we multiply by negative 3, then we're going to end up negative 3 times x squared is negative 3x squared. Negative 3 times y squared is negative 3y squared. And negative 3 times 25 is negative 75. Okay, so let's put the equations together so we could add them. So negative 3x squared plus 3x squared is going to be a 0. And negative 3y squared plus negative 16y, well, we can add those together, but we can put them next to each other, right? So we would end up with negative 3y squared minus 16y equals negative 75. So again, it ends up being quadratic. So we're going to need to solve this quadratic equation. And I'm going to use the handy dandy quadratic formula here. So we have b is negative 16. So we're going to have negative 16 plus or minus the square root of negative 16 squared minus 4 times a, which is negative 3, and then c is 75 divided by 2 times a, which is negative 3. So we simplify negative 16 squared is 256, and 4 times 3 times 75 is 900. And so we end up with 1,156. And the square root of that number is actually 34. So we're going to end up with two answers. One answer is 16 plus 34 divided by negative 6. So if we simplify that, we end up with negative 25 thirds. And then the second answer is the negative part, 16 minus 34 divided by negative 6. So we end up with 3. So we have two solutions for our y, but now we need the x. So let's work with y equals 3 first. So if I plug it in here, I'm going to get x squared plus 3 squared equals 25. And then 3 squared is 9. Subtract the 9, so we get a 4, plus or minus 4. So when y is equal to 3, we're actually getting two x's. We're getting a positive 4 and a negative 4. So just from this one equation, we're ending up with 4, 3 and negative 4, 3. However, we still have one more y equals negative 25 thirds. So I plug it in here again, and I end up with negative 25 thirds squared is 625 divided by 9. Subtract it, and this is going to give me a negative answer here. So if I take the square root, then I'll have an imaginary solution. So my only answer is going to be 4 thirds and negative 4, 3. So these are my solutions here. Any questions on that one? Would it be safe to assume when we have a circle and a parabola that there are either two solution points or none at all by chance? So I think it would at least have two, but I mean you could have, yeah, I mean two or none. The none might be a little bit more difficult depending on where the circle is located. But if you have a circle and a parabola, then you could actually even have four solutions, right? So you could have four solutions, you could have two solutions. The none part, let me see, let me clear that. I was gonna give you just a small little example here. If my circle is over here, the only way that this might not have a solution is if the parabola was opening downward. But if the parabola is opening upward, then eventually it's going to intersect it somewhere over here. So there is a possibility that there's no solution, but then you could have two solutions or you could have four solutions, depending how the circle is next to the parabola. Okay, here's another one. So let me give you maybe a minute to see how you would approach this, and then I will go ahead and start it.
So what way would you like to solve this one? The substitution or the elimination? Let's see. So let's go ahead and do what I believe would be the substitution method. I think it would be a lot easier. Yes, just because we have an x times y, um, we can't really, we can multiply this times another y or times another x, but it could be a little bit complicated. So our best option for this particular problem, I believe, is the substitution method. So let me go ahead and take over for Miss Chuka, just in case she got stuck. Um, so let's choose a variable to solve. So in our case, we always like to choose the x, right? So um, let's go ahead and solve for x. Okay. So on this first one, we grab the first equation and let's solve for x. So we add 1 on both sides. It's going to give us xy is equal to 1. Divide by y on both sides, so x is equal to 1 over y. So now we're going to replace this answer into our other equation, to the 3x minus 6y plus 17 equals 0. So again, everywhere I see x, I'm going to, um, oh, so Yvette's good. Um, Yvette, did you want to continue, or you want me, you don't
Oh,
mind me?
you can finish it.
All right, sounds good. Thank you. Um, I was getting lonely. That's why I jumped in. Sorry.
I know it's always it is hard to give students a minute because then it seems like 30 minutes, right? Whenever we say, oh, you have a minute and you're just in class and you're like that minute takes a long time.
A long time, right? I agree. All right, so I'm gonna go ahead and continue. So everywhere I see x on my second equation, I'm gonna plug in this value, 1 over y. So we have 3 times 1 over y minus 6y plus 17 equals 0. Okay, so let's go ahead and simplify. So here we have 3y minus 6y plus 17 is equal to 0. So one way we can get rid of the fraction is to multiply everything by y to get rid of it. So when I multiply y times 3 over y divided by 1 by y is 1. So 1 times 3 is 3. Um, Minus 6y times y is going to give me a minus 6y squared. Y times 17 is going to give me 17y, and y times 0, that's 0. Now, also, now that I'm here, it's very, very important that when we are multiplying, especially when we're using the elimination method, a lot of times I see students only multiply to half of the equation. So it's always good that if we're multiplying a number to our equations, we do it on both sides, or we do it to the whole thing. Let's not forget our right side, okay? So we have this equation, 3 minus 6y squared plus 17y equals to 0. So we need to solve for y, so we see that we have a quadratic again. Okay, so let's go ahead and use our quadratic equation. It always helps us on a bind when we cannot factor it, or we don't actually see it, or it's easy to factor. Our friend, our quadratic, will help us out all the time. So again, we plug in our values. My b is 17, my a is -6, my c is equal to 3. So when I do this, okay, I have minus 17 plus or minus the square root of 361 divided by a -12. So we have two solutions when we have the plus square root of 361 and with the minus square root of 361. So the square root of 361 is 19. So we have the plus 19. So we have minus 17 plus 19 divided by -12. So minus 17 plus 19 is a positive 2 divided by -12. So this simplifies to -1 over 6. Okay. Then the second one, we're using the -19. So -17 minus 19 divided by 12. -17 minus 19 is, should be a negative, or it is, sorry, -36 divided by a -12. So a negative divided by a negative is a positive, and 36 divided by 12 is 3. Okay, so we're going to do back substitution um, to get our two x answers. So we're going to have an x value for the -1, 6, and we're going to have an x value for the 3. So let's go ahead and do that. So let's start with the letting y equals -1/6. Let's plug it in to the first equation, the xy minus 1 equals to 0. So everywhere I see y, I'm going to plug in this value. So we have x times a -1/6 minus 1. If we simplify this, we have negative x divided by 6 equal to 1. I move the -1 to the other side. So to solve for x, I'm going to multiply both sides by a -6. So a -6 times a negative x over 6 gives me just x. And the -6 times 1 gives me that -6. All right. So let's go ahead and let y equals 3 now. So x times 3 minus 1 equals 0. So x times 3 is just 3x. Move the 1 to the other side again. So we have 3x is equal to 1. Divide both sides by 3, and x is equal to 1/3. So our solution set is 2 points, right? We have the first point is -6 and -1/6. And our second point in our solution set is 1/3 and 3. Okay. Any questions? So we still have a little bit of time. Does anybody want us to review a certain method or any questions that you've seen that you'd like to have answered? All right. Well, thank you. Ms. Chuka, do you have anything to add?
No, I just want to wish everybody well if you're taking your exam 3 this week, or maybe some of you are taking it next week. And if you have any questions, feel free to ask us.
Awesome, awesome. Alrighty, thank you so much to Ms. Chuka and Mr. Carizales for presenting today. Again, thank you to the audience for coming and being a wonderful audience. We hope you have a wonderful fall semester, and again, good luck on your exams. And know that online tutoring is here to help you out. I would like to invite you guys to next week's TVEs. Let me just share the calendar real quick. So next week on the 12th, we will be covering basic matrix operations and using matrix operations for the 1314 room. And then the 1324 will cover sets. So yeah, we hope to see you guys next week and have a wonderful day.